Welcome back. I'm so pleased you're taking the responsibility for your own learning and joining me on this exciting adventure to Mars. Before we get started, I'd like you just to remember that everything is connected by energy. That not only flows through our digital devices, but also through our lives as well. When you make this connection, it will all start to make sense. Just as certain people come into our lives to help us learn lessons, we have to feed information into computers for them to do something about what we want the computer to do. A question I'd like you to think about. Just as Axel is going to be learning and communicating with you, who has been the best teacher of something you never knew before? I'll repeat. Just as Axel is going to be learning and communicating with you, who has been the best teacher of something you never knew before? Okay, so we are teaching Axel to do certain things, and for it to do something, we need to feed it information. We call these inputs of information, what do you think we call them? Yes, inputs. In our next lesson, these are going to be what we are learning about. But before we go there, let's take a look at what we did in the last lesson. Let's have a quick review of what we've learned already. The progress bar. See the progress bar in the top right hand corner, number 1. Then we've got your robot feed. This is where students can see the robot and Axel's environment. It is expandable by clicking in the top right hand corner over here. The third area is the print preview, but we're going to deal with that at a later stage. Over here we have the instructions bubble. The instructions bubble containing tasks and instructions and theory are inputs of the problems we need to solve. Then number 5, we've got block drawers containing blocks organized by type. Remember, the blocks are actually program blocks. These are lists of instructions that the blocks have been given to do, and we get the opportunity to modify these sometimes. These are situated at number 5 over here. And then number 6, this is our workspace. This is where we can click to hide and reveal blocks added to the program, remove it from the program, etc., etc. This is where we click up to add the blocks to the program that we are writing. So last quick reminder before we move on. What is a program? Can you remember this? A program is a list of instructions that are done in a particular order to complete a task. Most programs have a core loop. Loops make programs do something over and over until the condition is met. These conditions often just repeat 5 times or repeat 10 times. Mom or dad might keep telling you to tidy your room, and until that condition is met, they're going to keep telling you this. I remember thinking to myself, would this recording ever stop? Only stops when you learn the lesson. Loops are common in day-to-day life for everyone. Okay, so do you remember? Just 4 batteries left to get. Use everything you've learned to help Axel collect them along the way. And what we did here, we learned about loops. And so we know here, Axel had to go 1, 2, 3, 4, 5, 6, 7 steps forward. So we went across to the movement draw, move forward by 1 meter, and then we needed to loop that. And if we looped it 7 times, let's just check that. 1, 2, 3, 4, 5, 6, 7. We repeat it 7 times. Those are the conditions that need to be met. So it's going to move forwards 1 meter 7 times. Press play. here. 2, 3, 4, 5, 6, 7, and so on. And so we learned about loops. Okay, so programs can look confusing. When we can see that programs think and do things pretty much the same way we think and do things, then we are beginning to understand the logic of computing. This is important. We have to know how the computer thinks, and you'll be surprised how this can help you in your daily life. Blocks are just instructions. We can change these instructions by changing the inputs. Blocks are just instructions. We can change the instruction results by changing the inputs. Here we can see 7 lines of code, and those purple ones are now your inputs. The arrows are showing the inputs we have been speaking about. So let's take a closer look at inputs. Remember, inputs are just added instructions you are given for the program to perform. This is terminology, things that you're going to have to say, that you should know how to say and get to know what they are fast. So pay attention. Drop-down menus, fields, block inputs. These are all terminology that you're going to have to understand. Drop-down menus cover limited options, left or right, up or down, forward or back. So when you drop down the menu, you're going to have a choice. Drop-down's options will be discrete. They won't be free in range, it will be much more narrow. Usually a good hint for what you're expected to do next. Fields can be inputs for a set range of values, like degrees. There's not just one degree, it's not just left or right. We've got a number of degrees. There's 360 degrees that you can choose. Volume, is it 5 milliliters, 10 milliliters? We're speaking about volume. It can also be for specific data. Numbers in fields in the field of math. 1, 2, 3, 4, 10, 20, 30. String fields in text. This is something a little bit more tricky and we need to get our minds around, but we'll get there. Block inputs are flexible. They let you give inputs on other blocks. Let you give inputs that will change as the program changes or runs. And it's not range limited. It can be limited to a type, the type if a block requires it. Another word we will get to know is parameter. Just repeat that after me, parameter. Parameters are different bits of information that we put in together to create the information that the block requires to do a specific task. Now this is where it gets fun. We're going to be connecting the inputs in the right block to collect the batteries. Okay, so here we have the instructions. These are the inputs that we're going to be inputting to make the robot. He's now facing up. We want him to turn right and go collect this block. When he gets to this block, he's going to turn left, and then he's going to move 2 steps forward to this block. Then he's going to turn right. Then he's going to move 1 step. And if we following the instructions here, we've got turn. What does he need to do? He needs to turn right. Then move 2 steps, 1, 2. Then he's got to turn left. He's turning left. Then he needs to move 2 steps, 1, 2. And then he needs to sorry, over here he needs to turn right. Turn left, sorry, turns left, and then he moves 2 steps. You get the message, you get the idea of what you need to do here. Okay, let's see how these input blocks work. Go to the instructions bubbles first to see what our instructions are. There seem to be some rocks in the way which you'll need to avoid. Clean up the oil and make sure that you include code to print what direction Axel is moving. Alright, so let's take a closer look at what Axel's doing here in the robot feed. He's got to move forward 2 times, then he's going to turn left, move forward 3 times, then turn right, and move forward 3 times. Over here, in between each move program block, a print has been inserted. So let's take a look what the print says. Let's go text box over here, and the instructions were clean up the oil and make sure you include code to print. Okay, so move forward by 2 meters and print left. Turn left, move forward by 3 meters, text, turn right. Okay, let's see what our code then does. And we want this to play through once, so let's use a loop. Duplicate that. So, press play. Let's just increase the view a little bit. 1, 2, print left, right, bada boom. Task done correctly. Okay, you can skip this next section if you want to get going, but let's continue. Let's do one more together. Okay, this looks interesting. It's got to move, turn left, move forward 1, turn left, move forward, move, turn left, move forward 1, turn left. Okay, this is interesting. So, let's have a look at the code that they've given us. I was saying turn left, it's turn right. So he's got to turn right, because if we change the perspective, he's got to turn right first. Then he's going to move forward by 3 meters. I don't think so. Turn left, move forward by 2 meters. I don't think so. Let's read the instructions. Our program is meant to have Axel clean up all of the oil. There seems to be 3 bugs in the code. Can you fix them? Okay, so we've already seen there are some bugs over here. So let's go back to the repeat in a few minutes. Let's first correct the code over here. So he's going to turn right, move forward by, that's right, 1 meter. Then he's going to turn left, move forward by 1 meter. That will take him to here. And you'll notice he's got to do the same thing over here, and over here, and over here. So how many times does he need to do it? 1, 2, 3, 4. So let's put 4 in there and see what happens. Hallelujah! Yep, it's been done correctly. Okay, so why don't you go ahead now and try and keep going. Keep going until you can't do any more. Okay, have fun. Okay, so let's take a look at what we've learned. We have drop-down menus that are limited or discrete. We have fields, and these can be of different ranges and can be typed. And we have block inputs. Okay, these blocks are flexible, typed, and can be variable in nature. Go on, see what you can do on your own, keep going, and when you hit a bit of a block, go back to the videos again or move on to the next video. Until such time, have a good time. Thank you for watching this video. I trust you have learned something new. In lesson 3, we'll be exploring loops for counting. If you have not registered yet, be sure to ask your parents to message ThinkSteam on +230 593 46944, and I'll be sure to send them a registration link. Don't forget that for each mission you complete, you'll automatically be collecting e+TOKENS that will earn you a place on the leaderboard, also known as the competition log. We are searching for the top 10 students in Mauritius in various competition categories. Don't forget to subscribe to us on YouTube, like us on Facebook, follow us on Instagram. So until next time, remember, find your passion, find your purpose, ThinkSteam, we're waiting for you.